All right, so welcome to Nerd Science. Time for more seasons. We're going to keep this thing going. And once again, you might be getting sick of it, but we got to just crank and crank on this until we get it. This tilted planets, with its axis tilted 23 and a half degrees off the plane that we orbit around the sun on. Since that tilt remains stable and we revolve, different parts of the Earth are exposed to the sun's energy, giving us seasons. So let's do this section now, and this is actually going to be kind of review, kind of repeating. So summer for we here in fact, all of these are for us because whoa, that's a big N. We'll stick with it. We here in the northern hemisphere, because one of the things we're going to get into with this and with the class activity, with all those little pieces of paper, if you've already done that, is that if you go to the southern hemisphere, all of this flops. You know, as let's say this is our summer, because it is, right? This is the beginning of our summer. We're leaning into the sun, but what flip yourself upside down and pretend you lived in the southern hemisphere down here, upside down on this diagram. They're not upside down in the southern hemisphere. Don't go with that misconception. Um, they're leaning back. They're having the short days now. They're having winter, the lower angle. Here in our winter, where we're leaning back, they're leaning into the sun. They're having their long days. They're having their more intense incoming solar radiation. So the seasons are flopped in the northern hemisphere and the southern hemisphere. So just keep that in mind. Most of the time, we're talking about us, of course. This is a New York State test you're going to face, so it's New York. But occasionally, they will throw a curveball at you and make you think about it from the southern hemisphere. Anywho, in the summer, we here in the northern hemisphere lean toward the sun, and in winter, we lean away from the sun. And the spring, fall, and I know I said this in the other video, which you're probably getting sick of hearing all this over and over again. But again, we got to repeat. If we're not leaning forward, we're not leaning away from, maybe we're leaning kind of sideways. All right. So what does this actually do on Earth? We still got to do that sun ray thing. That's going to be another time. We're going to jump over here to path of the sun. I mentioned this on the day that we did. It was actually during the fall equinox. I showed a couple of photos, and you know what? I should grab those photos. Quick pause. Okay. We looked at this is coming across what is it, 41, right by the church right there with the school over here. This is coming across where it crosses into Woods Road, crossing Route 11 onto the school property. This road, you can check it out on Google Earth, is very close to due east, due west. So right now I'm heading exactly east. If you drive this road around that season, you would have had the sun like shining right in your eyes as you drove into school. Now that's not happening anymore because the sunrise is creeping off in that direction. And if we come 6 months away from this date, this was during the fall equinox, it's going to go away for 3 months to the winter solstice, and it's going to come back for 3 months to the spring solstice. It'll be right back in our face, March 21st. And then it'll go that way and be at its maximum that way, right around Regent's time, June 21st. And then work its way back down until the next September 21st when you guys have all passed your science and you're here for your next year of school. Yeah, so, I mean, I took multiple photos. Back home, my road also is. Sorry, I got to open these. We kind of have the same situation at my house where we've got due west. So this is near sunset, near the equinox, right there. And again, during the winter, it will creep off that way, and then it will come back for the equinox, and then during the summer, it creeps off that way. So if you've noticed that trying to get into school here, that's great. You're already a head start here. So the easier ones to do are the equinoxes. Let's start there. The path of the sun. I'm probably going to go to a slightly smaller font here. Sunrise is due east. Sunset due west. Same thing down here for the fall equinox. Sunrise due east. Sunset due west. Get that in there. Now, if you know, like, hey, Mr. F, doesn't the sun always rise in the east? And yeah, it does rise in the east, like ish. If I go back to the school here, it's generally rising in the east. But what I'm going to say is that sometimes, like during the winter, it creeps down towards the south, and then during the summer, it creeps up towards the north. If you watch a lot of sunsets, like maybe up by Sandy Pond or Selkirk, you'll see that. Like, so summertime, beginning of summer, the sunset is north of west. It's way off to your right as you watch it. And then through the rest of the summer into fall, where it's exactly west, and now continuing into closer and closer to the winter solstice, it's going to be heading to your left, which is the south end of west. Tough stuff to picture. And it's why we got to deal with those celestial spheres and do a whole bunch. Not easy, not easy, not easy. So summer solstice, sunrise, is north of east, and sunset is north of west. Tough to picture. The next activity you do after this is going to help out with that, hopefully. The celestial spheres, those plastic domes we've been playing with in the back, are supposed to help with this. And it's why we got to do this so slow and piecemeal, because each one of these ideas is really complicated. When we get to the winter solstice, the sunrise is south of east. Sunset is south of west. So as a result, you get this kind of, if you were to watch it over the course of the year, if you could do it like fast time lapse, you'd be watching it go back and forth and back and forth and back and forth. Let me grab one other webpage. Okay, so I'm going to have you playing with this website for one of the activities we do. Hopefully, we should be doing that Monday-ish. But it's meant to mimic this celestial sphere right here. So this thing that you guys did in class, this is the same thing, only manipulatable by dates and by latitude and everything else, right? So I'm going to put it just a tiny touch further north, like where we live, somewhere in that ballpark. So this and this are the same thing. Now, I did this, we all did this in class, near the equinox. September 21. So you can see, and it was actually a couple days after. Let's do it for reals, what it looked like. You can see that the sun, like this and this are the same. How high the sun gets in the sky, its angle, it's tilted here towards the south, and it starts right about over here in the east and ends right about over in the west. Now, if we did it for exactly the equinox, it should be right on the money. Why is it not resetting? Anyway, we'll play with it in class. You'll see it. You can animate the sun. You can have it go through the course of the sky. You can change that. There's all kinds of stuff you can do with this little website. All right. So there is equinox. Go to December. Look how depressingly short that path is. Go to June. Look how big and long that path is. Those are the differences in the seasons right there. And see how the sunrise to the north, sunrise will be over here in the east. The sun rises to the north of east in the summer and to the north of west for the sunset. December is the opposite, to the south, and equinoxes should be right about on the money. All right, so let's just double check the notes, make sure we're good to go. Oh, too much stuff open. Tough stuff, but it's another one of the things that's got to be in there. I think we'll stop there. We'll call it good. We do have to figure out where the sun's overhead. That'll be the last part of these notes we do. For now, good luck. Thanks for hanging with me.